This is the third of 4 sessions on graphical representation of motion in a straight line. In this session we'll look at acceleration, and we'll look at acceleration represented on displacement time graphs. An object is accelerated if it either speeds up or slows down, or if it changes direction. Consider the motion of the object in this example. At time 0 the displacement is 2, at 1 second it's 3, and you see that the displacement continues to increase until after 11 seconds the displacement is 63 meters. The object keeps moving in the same direction, and each second the object travels further and further away from the starting point. To look at this more closely, we can see that between 0 and 6 seconds the object is speeding up. Between 6 seconds and 11 seconds the object is slowing down, but it's still travelling in the same direction. Observe the points on this graph and see what the graph looks like when the object is speeding up between 0 and 6 seconds, and what the graph looks like between 6 seconds and 11 seconds when the object is slowing down. Consider this example. Looking at the table first, at time 0 the displacement is 0, and after that the displacement increases, but you see after 5 seconds the displacement reaches a maximum, and then after that it decreases again until after 10 seconds the displacement is again 0. The key things you might observe are, between 0 and 5 seconds the object is moving further and further away from the starting point and the displacement is getting bigger, and then between 5 and 10 seconds the displacement is getting smaller. The object must be moving back towards its starting point. Let's take this step by step. Between 0 and 5 seconds the object is travelling away from the starting point to the right. The object has a positive velocity. The object is also slowing down, and the object stops at 5 seconds. Now between 5 and 10 seconds the object is travelling back towards the starting point. It is moving to the left. It has negative velocity, and also the object is speeding up. Consider this example. In this one, at time 0 the velocity is 3 meters per second. We're looking at velocity now. After 1 second the velocity is 5 meters per second, and that continues to increase until after 6 seconds the velocity is 15 meters per second. So, to summarize, the object is changing its velocity. It is accelerating. The velocity is increasing each second, and for example after 5 seconds the velocity is 13 meters per second. Let's look at what's happening second by second. Between 1 second and 2 seconds the object changes its velocity from 3 meters per second to a velocity of 5 meters per second. So the change in velocity is 2 meters per second. Now if we look at between 2 seconds and 3 seconds, the velocity changes from 5 meters per second to 7 meters per second. What's the change in velocity? It's 2 meters per second. The object is changing its velocity by the same amount and in the same direction every second. It's changing its velocity by 2 meters per second every second to the right. To summarize that, we would say the object has a constant acceleration of 2 meters per second squared, or it increases its velocity by the constant amount of 2 meters per second every second. And this is the end of the third session.